Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from SOFO Learning. In this video, we will study SSS or side theorem for similarity of triangles. I have two triangles over here, A, B, C and D, E, F. You might be familiar with it from our previous videos, and I have chosen P and Q in such a way that AB is equal to DP and AC is equal to DQ. Now we are given the fact that in the side model, we are given that the sides are in fact proportional. That means AB is proportional to DE in the same way as AC by DF, or AC and DF are proportional to BC and EF. So this side is proportional to this side base is proportional to this base, and this side is proportional to this side. All right, now what we want to think about, or what we want to prove here, is that angle A is equal to angle D. All right, this angle is equal to this angle, and so on. All three corresponding angles are equal, and that's how we prove that these two are in fact mathematically similar. All right, so let's begin our proofing process by looking at this portion, this first two terms, and replacing this AB with DP. All right, so instead of AB, let's do DP by DE is equal to, instead of AC, we will do DQ divided by DF. All right, now we will invert this, and we are going to subtract. We're going to make some adjustments by adding and subtracting 1 to both sides. So let me show you. So we will do DE divided by DP is equal to DF divided by DQ. Next, we are going to subtract 1 from both sides of this equation. So let me demonstrate that. So we're going to get, let's say, DE by DP minus, and we're going to do DP by DP. All right. What we want is this DE minus DP on the numerator and DP in the denominator. Now we got to do the same thing on the other side. So what we need to get is DF by DQ minus DQ by DQ. Now you can see these both are 1s and the equation is balanced. Now DE minus DP, what is that? DE minus DP is PE, right? So what we're going to get is PE by DP is equal to the same DP, and over here you get this entire length minus this much portion, or DF minus DQ, you get QF. So QF by DQ. All right, now this very clearly looks like basic proportionality theorem. This portion is the proportion between these two sides is equal to the proportion of these two sides. There is only one thing that it means. This means that PQ is running parallel to EF. That is essentially the meaning, and therefore this angle right here and this angle right here are basically equal. So that is the starting point. Now if two of the angles of a triangle are equal to each other, then the third angle would also be equal, because all of them has to add up to 180 anyway. So these two triangles are basically similar. That is what it is saying. So this angle is equal, this one are equal, and this top angle is common anyway. So what we have here is that the triangle DPQ is similar to to the triangle, what do we have, DEF, right? Now this brings up some interesting model, right? Because that means that this PQ and EF are essentially proportional to basically all the other sides, right? So let's write that down. Okay, I had to clean up the board to create some space, but what we said was this triangle DPQ is similar to DEF based on the fact that this line is parallel, and therefore these angles are the same, and therefore they are in parallel, etc., etc. Now from this point, what we need to think about is the fact that the sides are proportional, including this side, base side. All right. So let's write that down as an equation. We get dP by dE is equal to dQ by dF is equal to PQ by EF. Now this dP is equal to AB, all right? This dQ is equal to AC. So let's kind of replace these terms and see where it gets us. So this was AB, and this dQ, let's kind of replace this dQ with AC. All right. Now it looks like this: AB by DE, AC by DF, and therefore it is equal to BC by EF. Now we have something interesting. Now this PQ is exactly equal to BC just because of this portion. PQ and BC are equal. Now what this means is that these two triangles are congruent. Why? Because all three sides are exactly equal. So let's write that down. Triangle ABC is congruent to triangle DP and Q. Now we are just one step away from the proof. Okay, so let me just show you. Angle A is equal to angle D because these two are from a congruent triangle, and angle B is equal to angle P. All right, angle B is equal to angle P, which is also equal to angle E. We had proved that these lines are parallel, and therefore these two angles are the same. So this B and this E are the same. All right, that is good enough. The third angle has to be equal because all the angles put together must be 180. So there you have it. We have now proved that these angles are equal.